Question number 11. In this question we have to find out that which of the quantities or the equations are dimensionally correct. So the quantities or the equations are dimensionally correct when the left hand side and the right hand side have the same dimensions. Now let us proceed and solve this question. Now, dear student, the dimension of pressure is actually equal to ml minus 1 T minus 2, while the dimension of energy per unit volume is also equal to ml minus 1 T minus 2. Meaning that for this question, the dimensionally correct equation is straight away the first equation as we encounter in the options. And this is our final answer. Now let us proceed and solve the question number 12. In this question, the dimensional formula of the latent heat is given that it is identical to that of. So 4 options are given to us: internal energy, angular momentum, gravitational potential and electric potential. This one, latent heat is given as the heat per unit mass. So the dimension of latent heat will be equal to L2T minus 2. While the gravitational potential is also defined as the potential energy per unit mass. So in terms of dimension, we can put the square brackets, and the dimension will be equal to L2T minus 2. Meaning that for this question, the correct answer should be option number 3. Now let us proceed to the question number 13, dear student. In question 13, so 4 options or 4 statements are given. We have to find out the false statement. The first statement says a body can have zero velocity and still be accelerated. A body can have constant velocity and still have a varying speed. A body can have a constant speed and still have a varying velocity. Or the fourth option, the direction of the velocity of the body can change when its acceleration is constant. Dear student, herein the first statement is correct. One of the examples is when we throw a ball upwards, at the topmost point the velocity is 0, while there is an acceleration which is acceleration due to gravity downwards, and hence we can say that the body can have 0 velocity and still it can be accelerated. Now in the second statement it says that the body can have constant velocity and can have still varying speed. Dear student, it is an incorrect statement, because whenever the speed will change, the velocity will change itself, because the velocity or the instantaneous velocity is defined as the magnitude has a value equal to speed, while a direction as well is also incorporated in it. Now dear student, therefore statement 2 is incorrect, or we can say the statement 2 is false. Now moving on to the statement 3. The statement 3 says that a body can have constant speed and still have a varying velocity. This is possible. For example, in a circular motion with constant speed, a body can have constant speed. However, at any instant the velocity's direction is changing, therefore the velocity is variable. The fourth option says that the direction of velocity of a body can change when its acceleration is constant. It is also true. In the case of uniform circular motion, the acceleration can have constant magnitude but the velocity changes. Or a much better example is when we throw a ball upwards, there is a constant acceleration downwards g, and the body definitely changes the direction of velocity and moves downwards. So hence, after a brief discussion on the options, we can clearly see that the false statement or the correct answer for this question is option number 2. Now let us proceed to the question number 14. A lift is coming from 8th floor and is just about to reach 4th floor and stops there, taking ground floor as origin and positive direction upward for all quantities. Which of the following is correct? So 4 options are given to us, indicating the sign of x, v and a. X is the position, v is the velocity and a is the acceleration. Now dear students, let this be the 8th floor and this be the 4th floor and this be the ground where it is taken as origin. As we move upwards, x will be positive, while upwards velocity will be positive and upwards acceleration will be positive as well. As it is given that positive direction is upward for all the quantities, it is given that the lift moves down and is about to reach 4th floor. So the lift is moving down. This means that the velocity is less than 0, as it is downwards and upward direction is taken as positive. Now, as it stops, this means that the lift is retarding, meaning that the acceleration will be upwards and hence acceleration will be greater than 0. Now, as the lift is moving downwards, therefore the displacement of the particle x will be less than 0 as it is downwards. Considering all these signs, we can clearly see that the correct answer for this question is as per the given options, option number 1. Now let us move to the question number 15. In this question, a bus is traveling with 1/3 distance at a speed of 15 km per hour, next 1/3 at 20 km per hour, and last 1/3 at 40 km per hour. We have to find out the average speed of the bus. The student, let the total distance be 3x, then it is given that the x distance is traveled with 15 km per hour, further x distance with 20, and the further x distance with 40 km per hour. The average speed can be written as total distance, that is 3x divided by the total time. The time in individual journeys will be x by 15 plus x by 20 plus x by 40, as distance by speed is equal to time. Here x will get cancelled out and we'll be getting a value of 360 by 17 kilometers per hour. And as per the given options, we can clearly see that the correct answer for this question is option number 3.